uh, d by dx of sin x degrees. I think it is the seventh problem. Sin x degrees. At once we will answer it is equals to cos x degrees. It is equals to cos x degrees, but it is wrong. Okay, it is not equals to cos x degrees. Here it is. Okay, we have given d by dx of sin x is equals to what? Cos x. Yes, it is cos x. And at that time only I have mentioned this x must be in radians. Okay, so in front of trigonometric function sin, cos, etc. this variable represents the angles. No, sin. Look at the simple example. Sin 30 degrees is equals to half. Therefore, in front of trigonometric function here you are getting the angles. Therefore, x represents angles. So sin 30 degrees. Therefore, in front of trigonometric function you are getting the angles. Try to improve the basics. So you can overcome your weakness in your dullness or your weakness in any subject by improving your basics. Okay, if you are improving your basics automatically in every subject, you can improve yourself. X represents by setting some simple examples like sin 30 degrees half. Then you have to understand in front of trigonometric function angle will be there. The answer is half means it is a real number. Therefore, trigonometric function maps from angle to what it is real number. Okay, this type of simple what it is thinking you have to develop. Then you can overcome your weakness. Okay, in any subject it is. That is the basic point for the success in education. Basics should be improved by thinking yourself. So those you have to apply your mind. So you have to think rationally. Then automatically you can improve your education level. Okay. Anyway, d by dx of sin x is cos x. So here it is x represents the angle. So if angle unit is not mentioned, we are using two units for measuring the angles. Generally, there are some more units are there, but you are using so degrees and radians for measuring the angle. If unit is not mentioned, it is understood the angle is in radians. 3 means angle is 3. It is 3 degrees long. Angle is 3 means 3 radian. Unit is not mentioned means that unit is in radian. It is understood. Okay. Therefore, sin x is equals to cos x. Correct. When x is in radian. So radian is not mentioned. No need to mention the unit if the angle is in radian. Okay. If it is in degrees, then you have to mention x degrees. Okay. But here sin x is equals to cos x provided x is in radians. Here x is in radian because unit is not mentioned means the angle is in radian. Therefore, so sin x differentiation is cos x correct when x is in radian. Similarly, cos x differentiation minus sin x d by dx of sec x is sec x into tan x, d by dx of cosec x is minus cosec x into cot x, d by dx of tan x is sec square x, or when x is in radian. So if x unit is not mentioned, then it is understood in radian. But here it is clearly mentioned x is in degrees. When x is in degrees, it is not equals to cos 6 degrees. For all other remaining all of the trigonometric functions also same. D by dx of cos x degrees is not equals to minus sin x degrees. Then how to differentiate this one? Very interesting one. Therefore, now take d by dx of sin x degrees. Okay. We know that. So it is the first year syllabus. It is x degrees can be converted to radian by multiplying pi by 180 by multiplying the factor pi by 180 into x. Okay, radians. Rad means radians. Therefore, x degrees is equals to pi by 180 x radians. I told you no need to mention this unit radian. So x degrees is equals to pi by 180 into x. It is enough. It is understood. If unit is not mentioned, then it is in radian. By writing radian, there is nothing wrong in it. If you have written radian, there is nothing wrong in it, but no need to mention the unit if it is in radians. Okay. Therefore, I will write it as d by dx of sin of pi x upon 180. Okay. X degrees is equals to pi x by 180 radians. Okay. 180. Now look here. Here it is. In which form of differentiation here it is? It is sin f of x. We can put one more bracket for f of x. Pi x by 180 is f of x. Okay. So therefore here f of x is equals to pi x by 180. It is simply sin x. No. Sin something is there along with x, therefore it is to be taken as f of x. Something is there along with x, then it should be taken as what it is, f of x. What is the sin f of x differentiation now? It is coming to the sin f of x differentiation, cos f of x. What is the f of x here? Pi x by 180 into d by dx of f of x. What is the f of x here? F of x is pi x by 180. Okay. So now it is cos pi x by 180. It is unit is not mentioned, means it is in radians, into it is pi x by 180. Pi by 180 is constant into d by dx of x. Okay. That is cos of pi x by 180 into d by pi by 180 into d by dx of x is 1. Differentiation of x with respect to x is 1. Here dx upon dx cancels 1. That is the one. But it is lay sense of explaining d by dx of x is 1. Actually dx dx cancels, it is 1. It is a wrong procedure. But what is d by dx of x? X to the power 1, then x raised to n differentiation, n into x raised to n minus 1, 1 into x raised to 1 minus 1, 1 into x raised to 0, that is 1 into x raised to 0 is 1, 1 into 1 is 1. So that's why d by dx of x is 1. Therefore constant is taken in the beginning, pi by 180. What is pi x by 180 radian? Sorry, pi x by 180 radian is equals to x degrees. There is nothing wrong in writing cos x degrees now, because pi x by 180 radian is equals to x degrees. Or even cos pi x by 180 is written, there is nothing wrong in it. Okay. Similarly, I think here one same d by dx of tan x degrees. I think it is tan x degrees. Here problem. So same, if it is in degrees, you have to convert it into radian, because differentiation of trigonometric functions are taken when the angles are in radians. Okay. Therefore, it is d by dx of tan of pi x by 180. Okay. Again, tan f of x differentiation, tan f of x. Actually here one bracket is taken, it's well and good. If it is not taken, it is understood. For example, sin x by 2, although it is f of x form, you need to put bracket hence onwards, it is sin x by 2. Only single factor is there, so it is equals to sin x by 2. Only single factor is there, there is a single term is there is no need to put the bracket. But if it is sin of 2x plus 3, then, so if you are not putting the bracket, it seems to be sin 2x is one term, then 3 is a separate term. In that case, you have to put bracket. If really 2x plus 3 is single term, then it is a, but it is f of x. If 2x plus 3 is f of x, then better to put the bracket. In that case, you have to put the bracket. For single terms like that, sin x by 2, you can write it as sin. Without bracket, you can write it as sin x by 2. Okay. Here also, so pi x by 180, this bracket is not necessary. If there are 2 terms or 3 terms in plus or minus, then better to put the bracket for of. Okay, tan of pi x by 180. When this another second function is f of g, it is f of g. So this g is having a single term, no need of bracket. Bracket is taken, nothing wrong in it. If it is having 2 or 3 terms, then better to put bracket like this. Okay. These are all the basics. These are all the basics. So you can improve the mathematics by writing the terms properly. So by writing the terms properly, then you can improve your mathematics. Okay. Writing the terms properly is very essential in mathematics. Okay. Tan differentiation now. It is sec square tan differentiation. Tan sec square pi x by 180. Again, look here. It is not simply tan x. Tan f of x. What is the f of x here? Same. Pi x by 180. Therefore, into d by dx of pi x by 180, that's equals to sec square pi x by 180 into differentiation of pi x by 180, already explained above. It is pi by 180 outside, constant is taken outside, into d by dx of x. D by dx of x is 1. That's equals to pi by 180 is taken in the beginning, pi by 180 always. By writing the terms, sin first, then any numerical constants are there, that should be taken, and then the functions, variables like that. Okay, it is sec square pi x by 180, and write it as x degrees. Okay, 6 degrees. pi square 180 radians is nothing but 60 degrees. Okay. So that is the differentiation of trigonometric functions when the angle x is in degrees. We should convert it into radians first. Then it comes to the category of, they coming under the category of sin f of x, cos f of x, tan f of x, etc. Okay, I will take one more additional formula. So mind it, hence onwards, even though in detail we are differentiating the what it is composite function sin 3x plus 5 d by dx of sin 3x plus 5 is cos 3x plus 5 into d by dx of 3x plus 5, that's equals to 3 into 1, 3, and final answer is 3 sin 3x plus 5. Once you are well versed in thoroughly understand this composite function differentiation, then you should be in a position to write the derivative of composite function in a single step. For example, d by dx of sin 3x plus 5. At once you have to write 3 into cos 3x plus 5. d by dx of tan x by 2, that's equals to 1 by 2 into sec square x by 2. Straight away, okay, into d by dx of f of x should be taken in mind, then the answer should be written directly. You can save the time, okay. And for CET, JEE examinations, those shortcuts are very must, okay. No need, even in theory examination also, the evaluator is not expecting into d by dx of 2x plus 5, then 2 into 1, they are not expecting that one. Directly, if you have written d by dx of cos of sin x, if you have written minus sin of sin x, and in mind d by dx of into d by dx of sin x, then it is cos x. The final answer is, at once you can write d by dx of cos of sin x is minus the sin of sin x into cos x is written in value. Into d by dx of what it is f of x is actually not necessary, but you take d by dx of f of x in mind and enter the answer, enter the derivative of d by dx of f of x. Okay. Now I will take one more formula here. Look here, d by dx of 1 upon x raised to 6. We know the differentiation of x raised to 6, but we don't know the differentiation x raised to n. So far we don't know the differentiation of 1 upon x raised to n. Therefore what we have to do here is we have to convert 1 upon x raised to 6 to x raised to n form, because we know the differentiation of d by dx of x raised to n, not 1 upon x raised to n. So it is n into x raised to n minus 1, but 1 upon x raised to n, it belongs to the category of quotient formula. It is not equals to 1 upon 6 into x raised to 6 minus 1. Absolutely wrong, because the formula for d by dx of x raised to n is n into x raised to n minus 1, not it is the formula for d by dx of 1 upon x raised to n. I am going to give a formula for d by dx of 1 upon x raised to n. Okay, so look here, what we used to do using the x raised to n formula, d by dx of x raised to minus 6, because 1 upon x raised to 6 is 1 upon x raised to 6 is x raised to minus 6. The area of indices 1 upon a raised to m is a raised to minus 7. Okay, minus. Then it belongs to the category of x raised to n. d by dx of x raised to n, d by dx of x raised to n, n into n is minus 6. Okay, x raised to n minus 1, minus 6 minus 1. d by dx of x raised to n is n into x raised to n minus 1. n is minus 6, n is any real number except 0 in d by dx of x raised to n formula. Okay, it is minus 6 into x raised to minus 7. Now minus of 6 upon x raised to 7. This minus actually should be taken not to the minus, it is taken to the middle. Means taken should be minus, whenever minus term is there, numerator upon denominator is there, that should be taken in the middle. Means it is in front of division sign, should be taken as the correct number of it. Okay. This is the answer. Now I will derive one formula here. I will do one formula d by dx of 1 upon x raised to n. Then straight away I can differentiate it without converting it into x raised to n. Here is the formula. It is minus n upon x raised to n plus 1. Okay. Here is the formula for d by dx of 1 upon x raised to n. Okay. Whenever 1 upon x raised to n is there, converting it into x raised to n, then differentiation waste of time. So one step I can get the answer. It is minus n upon x raised to n plus 1. So 1 year, 2-3 years back, or 3-4 years back, one question was asked d by dx of 1 upon x square in CET. Mind that one. It is minus 2 upon x raised to 2 plus 1. Okay, for example, d by dx of 1 upon x raised to 6. Same problem. By this formula, I am not using x raised to n formula, I am directly using 1 upon x raised to n formula. Okay, that's it. So, what is the n here? It is in the category of 1 upon x raised to n. So, n is 6. Therefore, this formula suits here. Okay, of course, I can do it by like this also. Best of time. It is 1 upon x raised to 6. 1 upon x raised to n. N minus n. N is 6 here. Okay, n is 6. Comparing with 1 upon x raised to n. Here, n is 6. Therefore, minus n, minus 6 upon x raised to 6 plus 1. Put here minus 6 upon x raised to 7. In one step, I can get the answer. Here, 2, 3, 4 steps are necessary. In one step, minus n upon x raised to n plus 1. What is the d by dx of 1 by x? Tell me that. One more example. D by dx of 1 by x, that's equals to x means x to the power 1, no? D by dx of 1 upon x to the power 1. N is 1, therefore minus n minus 1 upon x raised to n plus 1, 1 plus 1, 2. Like this. You have to write some calculation directly. For a simple calculation, 1 plus 1, you don't waste steps. So, for CET and JEE, that time maintaining is very important, time factor is very important one. Simply writing what when you are not getting sufficient space for writing also in CET and JEE. That's why. So try to write simple calculations directly. Okay? Try to practice it. By practicing you can get everything. Now, so parallel to 1 upon x raised to n. Parallel to 1 upon x raised to n. Tell me one more problem. D by dx of one more problem. Let's see. 1 upon cube root of x raised to 5. I told you that day only I told x raised to cube root of x raised to p is equals to x raised to p by q. X raised to p by q is equals to therefore it is the basic theory of indices formula. Here it is cube root of x raised to 5. Here the radical index is 3. It means it is equals to what? D by dx of, right here, d by dx of, it is 1 upon x raised to 5. I am teaching by keeping the average students in mind. Actually for clever student, this type of explanation seems to be somewhat boring, okay? But I am teaching by keeping the average student in mind. So average students, if you are skipping all these steps, they are not following the things. So, but if you are writing like this, explaining each and every minute things, there is no problem for even clever students also. Even though you are feeling somewhat boring, but no problem. But at the same time, every student can answer, understand all these basic mathematics. My main motto is like that only. Every student should improve in their basics. Keeping that point, I am explaining each and every, but it is basic mathematics while teaching. If you are once you have understood the basic mathematics, mathematics is not a difficult subject, but you have to understand the basic mathematics like LCM, theory of indices, taking LCM, factorization, rationalization, all these basic mathematics should be improved. Then automatically mathematics will become a simple subject. It is n is 5 by 3. It is the category of 1 upon x raised to n here. This belongs to the category of 1 upon x raised to n. N is what? 5 by 3. I told you n is any real number except 0. Here also n is any real number except 0. In that formula of d by dx of 1 upon x raised to n, you write like this: minus n upon x raised to n plus 1, where n belongs to any real number except minus 0. Okay. So this you include n is any real number, maybe whole number, positive whole number, negative whole numbers, or even fractions 3 by 2, 4 by 5, irrational numbers like 2, 3, etc. But n should not be equals to 0. So here it is n is 5 by 3. That's why n may be only integers. N may be even fractions also. Okay, 5 by 3, rational number 5 by 3, 2 by 3. N may be irrational numbers also. N is 2, root 3, etc. Okay. That is, now n is 5 by 3. Therefore minus n, minus 5 by 3 upon x raised to 5 by 3 n plus 1. Okay. So it is minus 5 by 3 upon x raised to 5 by 3 plus 1 LCM. 3 into 1 is 3, 5 plus 3 is 8. Therefore it is 8 upon 3. How it is 8 by 3? Here 1, if LCM is taken for this one, 3 multiplies, because 1 will be 5 by 3 plus 1. Okay, 1 means 1 by 1. No? LCM of 3 and 1 is 3. Now, LCM is to be multiplied for each and every fractions. Here 3 is multiplied in my mind. 3 ones are 3. 1 into 5 is 5. Because here also this fraction is also multiplied by 3. So 3's are 3. 3 into 1 is 3. Therefore it is 8 by 3. Okay. Now it is 8 by 3. Okay, what is the 8 by 3? Let us write minus in the middle. 5 upon 3 into what it is 1 upon x raised to 8 by 3. 1 upon means 1 upon. Now x raised to 8 by 3. So I can write it in the square root in the what it is. With the symbolically I can write it as 1 upon with the cube root of x raised to 8. No, cube root of x raised to 8. Finally, so I can write like this minus 5 upon 3 into. I will have taken the bracket because we are confusing this 3 and this 3. This is radical index. This is 3 coefficient. 3 into x raised to 8. In the coefficient 3, this 3 the coefficient of cube root of x raised to 8. This cube root is radical index. It is inside the v sign is written. No, that is the radical index. Now I will extend d by dx of 1 upon x raised to n is equals to minus n upon x raised to n plus 1. N belongs to R, any real number except 0. N is any real number. N belongs to means n is any real number except 0. To a composite function, that is d by dx of 1 upon in place of x, any function of x raised to n is there, then it is minus n upon, say minus n upon, the minus should be taken the middle of, in front of it, division. Okay, minus n upon, it is f of x raised to same n plus 1, okay, x raised to n plus 1, f of x raised to n plus 1 into d by dx of f of x. As usual, whenever composite function is there in place of x, f of x is the same formula words good, but into d by dx of f of x means d by dx of f of x is taken as f dash of x is additional. That's all. Okay. Now let us solve some problem on this particular formula. D by dx of, for example, 1 upon sin x plus cos x. Okay. That's it. So sin x plus cos x means sin x plus cos x to the power 1. The d by dx of 1 upon sin x plus cos x whole raised to 1. If you understood this formula, you can avoid the quotient. It is of the form numerator upon denominator, therefore you can avoid the quotient. I told you, either in numerator there is a constant or denominator there is a constant, you can avoid the quotient. In both numerator and denominators are having the variable x or the functions of x, then quotient formula u upon v formula should be taken. Here numerator is one constant. Therefore no need of quotient formula. Use this particular formula. It is minus n is 1 now. Minus 1 upon what it is, sin x plus cos x raised to 1 plus 1 into d by n plus 1 into d by dx of, time being we write minus in the numerator. In the final answer you should the minus to the middle. Okay, d by dx of, it is f of x. What is the f of x here? Sin x plus cos x. Here f of x is equal to sin x plus cos x. F of x is equal to sin x plus cos x. Okay. Now I have to differentiate this sin x plus cos x. D by dx of sin x plus d by dx of cos x. Whenever it is in the plus or minus form, we will differentiate each and every term. That's equals to minus 1 upon sin x plus cos x into differentiation of sin x is cos x plus differentiation of cos x, that is minus sin x plus of minus, it is in the plus or minus form, therefore it is d by dx of sin x, that's cos x plus d by dx of cos x minus sin x. It should be equal. Mind that one, into f of x always multiplies to this left hand side term. Okay, therefore in bracket. the whole term multiplies. Therefore, in need, I can write it as minus, I will take the minus in the middle. It is cos x minus sin x divided by sin x plus cos x. Okay. So that is the d by dx of 1 upon f of x raised to n. One more example I will take d by dx of second example, d by dx of 1 upon 3x raised to 4 minus 5x squared plus 10 whole raised to 4. Okay, whole raised to 4. That's equals to, it is f of x, 1 upon f of x raised to n. It is exactly the form of 1 upon f of x raised to n, 1 upon f of x raised to n. N is 4 here. That's equals to minus n minus 4 upon minus n upon f of x raised to n plus 1, 3x raised to 4 minus 5x square plus 10 raised to 4 plus 1, 5. Understood? 4 plus 1 is 5 into d by dx of 3x raised to 4 minus 5x square plus 10. That's all. Now I have to differentiate this one, d by dx of 3x raised to 4 minus 5x square plus 10. Mind that 1. This type of differentiation should be written directly. Okay, plus or minus means you have to differentiate each and every terms. 3 constant, d by dx of x raised to 4, x raised to 4 is 4x cube. 3 4s are 12x cube minus 5 outside. D by dx of x square constant is there, constant should be taken outside into d by dx of x square differentiation is 2x, 5 to the 10x plus d by dx of pure constant 10, that's 0. Therefore, it is minus 4 upon minus, better to write minus in the along with n only. Later on we take this minus to the middle. Okay. So it is minus 4 upon 3x raised to 4 minus 5x square plus 10 whole raised to 5 into, I will write directly 3x raised to 4 differentiation, 3 out, x raised to 4 differentiation, that's equals to 4x cube, 4 into x raised to 4 minus 1 is 4x cube, minus 5 out, differentiation of x square, 2x, 5 into 2x, plus 10 differentiation is 0. Okay. That's equals to, finally it is 3, 4, that 12x cube, it is minus 4 into, now I will take the minus in the middle. So far you take minus in the numerator. Okay. 4 into 3, 4, that 12x cube, minus 5 into 2 is 10x, that's all, upon 3x raised to 4 minus 5x square plus 10 whole raised to 5. That's why in d by dx of 1 upon x raised to n, for convenience take minus in the numerator. Finally you take it in the middle. Okay, it is the structured way of writing. Okay, otherwise minus in the numerator, nothing wrong in it. X raised to n plus 1, even d by dx of 1 upon f of x raised to n also. That's equals to minus n upon f of x raised to n plus 1 into d by dx of f of x. Okay, we take minus in the numerator and there is no confusion. Later, finally, we take minus to the middle. Okay, that's all. So, can I try one more? D by dx of, last one, say 1 upon, it is cube root of, it is sec x. Okay, cube root of sec x. What is the cube root of sec x? It is d by dx of 1 upon sec x raised to 1 by 3. Okay, nth root of x is equal to x raised to 1. Try to understand this basically. Nth root of, here the radical index is n. That index number comes inside the v side. Okay, 1 upon x raised to n. Therefore, it is of the form 1 upon f of x raised to n, exactly the numerator 1. So, instead of 1, if it is 2 is there, then what to do? That 2 is taken outside. Any constant is there, nothing wrong in it. By taking that one outside, put 2 outside into d by dx of 1 upon 2 is taken outside, then 2 is nothing but 2 into 1, 1 remains here. If any additional constant is there, nothing to bother about it. That constant should be taken outside, that's all. That's equals to, now f of x is what? Sec x raised to 1 by 3. Okay. Sec x raised to 1 by 3. Sorry, sec x. Sec x is f of x. And what is the n here? N is 1 by 3. No. Exactly the form of 1 upon f of x. It's 10 by 3. It is 2 into minus n minus 1 by 3 into f of x upon f of x raised to n plus 1. N is 1 by 3. And that not minus 1 by 3. Here the formula says that it is minus n. No. Formula says that it is minus n. Therefore it is minus 1 by 3 into sec x raised to n plus 1. 1 by 3 plus 1. N is 1 by 3. That is minus 2 upon 3. Oh, I'm sorry. Into d by dx of into d by dx of f of x sec x d by dx of f of x raised to n minus n upon f of x raised to n plus 1 into d by dx of this f of x. So the two constant taken outside. It is minus 2 by 3, 2 into 1 by 3, 2 by 3 minus plus minus c minus upon 1 by 3 plus 1. 3 ones are 3, 3 plus 1 is 4 by 3. Sec x raised to 4 by 3 into differentiation of sec x. Sec x differentiation is sec x tan x. Now finally in systematic manner break it. That's equals to minus in the middle 2 upon 3. 2 into what? The numerator sec x plus tan x. In the denominator is sec x raised to 3 into sec x raised to what it is? 4 by 3. Okay. Sec x raised to 4 by 3. This is 2 by 3. This 3 denominator comes here. Okay. This 3 comes here because a by b upon c to a by b c. Okay. But what about a upon b by c? Here numerator is having two terms a by b upon c. That's equals to a by bc. But what about a upon b by c? Denominator is b by c. That equals to ac upon b. Alright, okay, I will do the explanation for it both. With a upon b is the numerator and denominator is c. This one. Okay, c means c by 1. Now multiplication with a by b into 1 by c. A by b upon c by d is a by b into what it is d by c. Denominator is converted to multiplication. Division can be converted to multiplication by taking the reciprocal. C by 1 is 1 by c. That's equals to a by bc. And for the second one, we can a upon b by c. So denominator is only b by c. The numerator is a 1. I can write it as a by 1 divided by b by c. Again multiplication. A can be written as a by 1. Nothing wrong in writing a as a into 1 or a upon both is a only. A upon 1 is a. Therefore it is equals to a by 1 into multiplication. Division converts to multiplication by taking the reciprocal. That's equals to AC upon A into C, AC upon A into B is B. So these are all things after the basics are to be remembered so that you can improve your mathematics and at the same time you can write the things quickly. It is minus 2 by 3 into sec x plus tan x. I can write it as it is cube root of sec x raised to sec x whole raised to 4 is sec raised to 4x. Sec means secant. Sec in the sense secant x. Sec x I pronounce it as sec x. Sec x means secant x. Sec x raised to 4 because any trigonometric function raised to n is that n comes here. But upon 3 that means it is cube root. Okay. That's all. Okay. So that is the differentiation of 1 upon f of x raised to n. Now let us take some examples from this NCERT textbook. This NCERT textbook is prescribed textbook even for second year science students of PU board of Karnataka. At the same time, the majority of the problems in this textbook is actually NCERT textbook, central syllabus textbook, and some extracted portion is taken. Not extracted, almost all quantitative portion is taken from the NCERT for PUC second year science students of Karnataka PU board. Okay, it is exactly central syllabus textbook. Okay, let's take one by one problem. from the textbook. Differentiate the following with respect to x. Differentiate the following with respect to x. It means this textbook is for PU2 second year science students of Karnataka board, PU board, as well as it is the textbook of central syllabus. Now, d by d, differentiate the following with respect to x. Differentiate the following with respect to x. First one, sine of x square plus 5. And second one is cos of sin x. And third one is, it is sin ax plus b upon cos cx plus d. Cos cx plus d, where a, b, c, d are constant. I told now in simple differentiation a, b, c, d, f, g, h, i, j, k, l, m, n, o, p, q, r are generally represents constant. S, t, u, v, w, x, y, z, theta represent variables. Okay. And next one is, it is sec of, fourth one, sec of tan of root x. Okay, one by one. Let's take d by dx of first one, d by dx of sine of x square plus 5. Now you are in the sine f of x form. It is not only sine, it is sine f of x. So it is d by dx of sine f of x. Orally, I will take the form. I won't repeat the formula again and again by writing. Orally, I will tell. D by dx of sin f of x is equals to cos f of x into d by dx of f of x. Because you can repeat the video again and again and get the idea which formula is used by thinking yourself, because it is already explained. No? Listen what we are explaining, then think over which formula is applied later on. Therefore it is f of x is x square plus 5, therefore it is cos of x square plus 5 into d by dx of, it is f of x is x square plus 5, that's equals to cos of x square plus 5 into differentiation of x square on 2x, x square, 2 into x raised to 2 minus 1, x raised to differentiation, 2 into x raised to 2 minus 1, 2 minus 1 is 1, x to the power 1 means x, plus 5 differentiation, 0. Final answer is 2x, is 2x plus 0 means 2x is taken the beginning. Cos of x square plus 5. Okay. Second one, cos of sin x, d by dx of cos of sin x. Tell me, it is in which form? Cos f of x. In the cos f of differentiation, d by dx of cos f of x is minus sin f of x. F of x remains as it is here. F of x is sin x, cos f of x. Okay. D by dx of sin f of x, cos f of x, this f of x remains same, into d by dx of f of x. Here also f of x is sin x. Therefore d by dx of cos f of x is minus sin f of x into d by dx of this f of x is sin x. Minus sin of sin x, cos f of x differentiation, minus sin f of x remains same here, into d by dx of that f of x. Minus sin of sin x into sin x differentiation, simple differentiation, cos x. Good. Okay, this cos x is a separate factor and sin of sin x is one factor. But it is in the composite form, it is simple function. Okay, so therefore it is minus cos x, but it will take minus cos x in the beginning, it is sin of sin x. That's all. Okay. Now, third one, sin of ax plus b upon cos of cx plus d. Differentiate with respect to x means you have to take d by dx. D by dx of sin ax plus b upon cos cx plus d. D by dx of sin ax plus b upon cos cx plus d. Overall, minus 1, it is in the quotient form. Is it not? Quotient form. Numerator is also x, denominator is also x, therefore it is a quotient, it is in the form of u by v. Try to first of all apply the quotient form. Even though it is a composite function, if it is in the quotient or in the product, first those quotient and product formula should be taken first. Then while differentiating each and every term, you have to apply the composite function, if it is really composite function, if it is simple function, apply the simple function differentiation formula. That's all. First of all, quotient formula. What the quotient formula says? In the denominator the whole square. Cos of cx plus d the whole square. In the denominator cos of cx plus d into d by dx of numerator sin of ax plus d. Okay. Minus numerator sin of ax plus d into space is not sufficient, apply like into actually should be here into like this d by dx of cos of cx plus d. No? Here it comes into d by dx of cos of cx plus d. Now differentiation. Sin of ax plus d differentiation. Can you tell me directly what is d by dx of sin of ax plus b? Cos of cx plus d as it is into the sin f of x differentiation. Okay? Try to write the things directly. Sin differentiation is cos ax plus b sin f of x into d by dx of ax plus b. What is the d by dx of ax plus b? A constant, d by dx of x is 1, a into 1, a plus b pure constant 0, therefore it is into a. Understood? Minus sin of ax plus b into differentiation of cos cx plus d. It is cos cx plus d. Cos differentiation is what? Into minus sin cx plus d into differentiation of cx plus d. It is in the form of cos f of x. Cos f of x differentiation minus sin f of x. Minus sin f of x into d by dx of cx plus d. What is the cx plus d differentiation as usual? C into d by dx of x is 1 plus d pure constant 0. C into 1 is c. Let us rewrite it again in the systematic manner. It is cos square cx plus d. Cos square because cos theta whole raised to n is cos square theta. Look, you can write like this: cos theta whole raised to n is cos raised to n theta. Okay, I will, in the side I will write it. D by dx of sin ax plus b. Same for cos. Okay, cos cx plus d. It is equals to sin differentiation cos ax plus b into d by dx of sin f of x differentiation cos f of x into d by dx of ax plus b. It is cos ax plus b into differentiation of ax plus b. That's equals to a into d by dx of ax. Even stepwise I will write. But this stepwise writing is not warranted, actually not necessary. For the understanding sake I am explaining all these things. Direct entry is always far better. Plus d by dx of b. D by dx of ax plus b, a constant. That's equals to cos ax plus b into a outside d by dx of x plus b differentiation 0. That's equals to cos ax plus b into a into differentiation of x is 1. Okay, therefore it is a cos ax plus b. Therefore, hence onwards, you should be in a position to differentiate sin ax plus b directly. The answer is a cos ax plus b. Okay, as a shortcut, I will give some shortcut formulas later. Okay, not necessary. All these are really unnecessary. D by dx of sin ax plus b is sin differentiation cos ax plus b into differentiation of ax plus b in mind. A outside differentiation of x is 1 and b differentiation is 0. Because ax plus b is in the plus or minus form. In that case, you have to differentiate each and every terms. Any constant in that constant you take outside, differentiate the variable. Then you will get a into 1 plus b pure constant, differentiation is 0. That's why finally it is cos into cos square I can write. Because here cx plus d, here ax plus d, angles are different. Cos 30 into cos 40 is not equal to cos square 30 into 40. It is, angle should be same, cos theta into cos theta, angle is same theta, then cos square theta. Otherwise it is as it is. Cos x into cos y is cos x cos y. It is a in the beginning, a into cos of cx plus d into cos of ax plus b minus, it is minus of minus is plus c into here is constant c. No? Similarly, differentiation of what it is cos cx plus d is minus sin cx plus d into differentiation of cx plus d is c. c into the sin ax plus b into cos sin cx plus d, no? It should be taken in front of here, this into should be taken here, but due to lack of space, shortage of space, I have written down. Actually this term comes here into sin of cx plus d divided by cos square cx plus d. Okay. Now last one, d by dx of fourth one, d by dx of what it is, sec of tan x, d by dx of a somewhat extended problem, little bit attention is required here, sec of what it is, d by dx of sec of tan x. It is function of function of function. Not only two functions is involved here. F is sec, okay, sec function, and g is tan function, and root x is h function. Therefore, it is f of g of h of x. Okay, finally x. Therefore, h of g is what? Root function. G is the h is the root function. Finally x. Therefore, h of x is root x. H of x is root x. Okay. Therefore, it is g of f of g of h of x. Function of function. Okay. So as usual, but whatever it may be, first of all sec is there, no? Differentiate sec. It is sec differentiation. It is sec differentiation is sec f of x into tan f of x. F of x is what here? Time being f of x you take it as tan root x in front of sec tan root x. The time being take f of x as tan root x. Therefore it is sec of tan root x into d by dx of tan root x. Tan root x. Now, therefore, what is this? Oh, I'm sorry, myself went wrong. What is the sec differentiation? Sec differentiation, sec into tan. Okay, sec into tan. Tan of tan root x. What is the sec x differentiation? It is sec f of x into tan f of x. Sec f of x differentiation. I will write here d by dx of sec x is sec x into tan x. Sec f of x is what? It is equals to sec f of x into tan f of x into d by dx of f of x. Am I right? I am going a little bit speed. If you are not catching with my speed, then revise the video. What is wrong in it? Revise the video. Video repeat ಮಾಡಿ. Into d by dx of what? F of x. Tan root x. You can have the pause option. That's why in any junction, I am a little bit speed. Have the pause option. Okay, repeat it. It is sec tan root x into sec f of x differentiation, sec f of x into tan f of x into d by dx of f of x. What is the f of x here? Sec tan root x. Okay, sec f of x. This is f of x. Now I have differentiate tan f of x. You can, now it is tan x is not there, tan root x is there. Okay, tan root x. For the tan root x, it is not tan x simply, tan root x. Therefore, it is also in the form of tan f of x. Therefore, the differentiation of tan f of x, sec square f of x into d by dx of f of x. The sec of tan root x into tan of tan root x into tan differentiation sec square root x into d by dx of root x. Okay, why d by dx of root x? You are getting? Because here I am writing the formula d by dx of tan f of x. For this one, f of x is tan root x. For this one, f of x is root x. For this tan f of x form, it is in the tan f of x form. Tan f of x form. What is the f of x? Tan x is not there. So along with this, some additional is there. Therefore, it is tan f of x. Therefore, what is the f of x here? Root x. D by dx of tan f of x is what? Tan differentiation sec square root x. Sorry, sec square f of x into d by dx of f of x. Now, whatever I am writing on the side and putting round like this, that is not the main part, explanatory part. Okay. So, if you are not understood, those explanations can be referred. So, for main solution, These are all not necessary in the examination. Okay. Now, what is the root? Now, finally, I have to differentiate root x. Okay. What is the root x differentiation? 1 upon root x. Therefore, it is sec of tan root x into tan of tan root x into sec square root x. What is the differentiation of root x? A short formula is given. Root x differentiation 1 by 2 root x. Remember, it is 1 by 2 root x. Okay, because root x is x raised to half. X raised to half differentiation 1 by 2 into x raised to half minus 1 is x raised to half minus 1 is minus of half into x raised to minus of x raised to minus half is 1 upon x raised to half. X raised to half is root x. Root x means x raised to half. Finally, so it is sec of tan root x 1 by 2. Root x I will write it in the beginning. Okay, that 1 by 2 root x. Sec tan root x tan root x into sec square root x. Okay, that is my final answer. Even 1 by 2 root x can be divided whole 1 by 2 root x, nothing wrong in it. Okay, this is the answer. Even you can write like this. Whole 1 by 2 root x, one in the same